Let's go ahead and kick it off, Nikki.
Sounds good. Well, thanks for joining us, everyone. We're super excited to have you here. Today, we will be talking about LLMs, specifically how you can support and build LLMs using Redis as a vector database and Featureform as a feature store. So Simba is going to lead this conversation, but a couple of points that we'll definitely try to cover is first off, like, how does a feature store and a vector database even work? I mean, is that just duplicative? Like, what's the value that both these components bring together? We'll talk about how that will improve your LLM performance, right? Because at the end of the day, if you build a super cool app or pipeline, you want it to work. And finally, Simba will kind of share tips and tricks that he's learned both through working with recommender systems for Triton, for a ton of companies that you've heard of, but also more recently, the work that we've been doing on the Featureform side to support LLMs in production, even some like fun use cases that he's seen, and some learnings around that. So we're really excited that you could join us for both people who are participating, people who are viewing, and of course, feel free to just drop in questions as we go on. Yeah, and then to introduce everyone, if you don't already know Simba, Simba is the CEO and founder of Featureform. Prior to Featureform, he has done a number of startups, like all in essentially the the data side of ML. So a couple like projects include Embedding Hub, Stream SQL, and now Featureform, the primary open source virtual feature store that's out like on the market now. Yeah, so, and actually let me go ahead, and Simba, you have the floor.
Great, thanks, Mikiko. I'm going to go ahead and share my screen. And I will do this tab. Okay. So like Mickey said, I'm going to talk a lot about LLMs. I'm mostly going to talk about how private data works in an LLM world. Like, how can you unlock the value of all the data you have on users, content, etc., to take something like ChatGPT or whatever, Llama 2, and make it usable for your use case, like be able to contextualize it with the data you have. Specifically, in this case, I'm going to build a Q&A bot on our podcast. So we have an MLOps weekly podcast. And at the end of this, I'm going to show a demo where I actually build a chat bot with the podcast. So I will use our podcast transcripts to contextualize an LLM and allow you to ask questions to this podcast that for sure ChatGPT was not trained on. So agenda, we're gonna, I'll do a quick overview. I'm gonna talk about the concepts of zero-shot learning, few-shot learning, and many-shot learning, sometimes referred to as fine-tuning. I'll talk about the workflow commonly called RAG, Retrieval Augmented Generation, what that means, what it looks like, how it works, essentially how to structure your prompts for maximizing performance. I'll give a full demo using Featureform, Redis, specifically Redis Labs, in this case, hosted Redis with vector search, and AWS, so S3, Kubernetes, etc. Yeah, so like Mickey said, I'm Simba, founder CEO here at Featureform. I have worked on a variety of different things over my career as a software engineer at Google. I built a recommender system that was handling 100 million monthly active users at my last company. And Featureform was actually built internally there. So for that recommender system we built, we essentially built this thing to solve our own problem. We called our data platform. Nowadays, it would be called a feature store. So what is Featureform? Featureform is a way to define, manage, and run your data pipelines. It's an orchestration tool and a definition management tool. Where it's streaming, it's LLM focused, it's local, it's running in the cloud, all of the above, we can do it. We really focus on versioning, reuse, and search and discovery. And in this situation, especially, you kind of see how lots of the goal here is essentially connect your data to your models and everything that happens in between. So everything between the data and the model, that whole like orchestration and management and that workflow is what we do. So in a sense, we're a Python framework for all the data parts of machine learning and LLM workflows, which I will show are actually quite similar in many ways. To that point, we're a feature store. We call ourselves a virtual feature store. In practice, a feature is just an input to a model. And funny enough, not necessarily by design, it just kind of was emergently clear that people were using Featureform for LLM use cases. So the way Featureform was built, the way we were all about kind of this data pipelining, made it so it was really easy to extend it, to use it for prompts, for embeddings, and for other things, which again, of course, I'll show. But the main point here is that a feature is an input to a model. So a feature might be something like the last 5 things the user clicked on. Well, that could be an input to a traditional model. That could actually be taken and then structured into a prompt. Yeah. In the LLM use case, all of these different types of features are used. I'll show that, like analytical features are used, embeddings are used, and prompts are used. The whole point of all of this, like why do we even talk about data and private data in this use case, is about context. It's about contextualizing our prompts so that we can give and maximize the amount of information that we provide, relevant information that we provide ChatGPT or whatever with every single request to allow it to, one, not hallucinate, do a much better job, and use data that it might not have access to otherwise. Like I said, at any point in time, if you have any questions, feel free to throw them in chat. When I have more, there's some breakpoints through it where I will go and check it out. So let's talk about the basic zero-shot LLM use case. In the basic use case, you are writing a query, or you have a query, like you have some idea in your head. You templatize into a prompt, and that could just be like writing it out in a way that you think will allow the LLM to do the best job and give you the best possible response. For example, you might say like, explain like I'm 5, like what is an LLM? That is prompt engineering. With zero shot though, the only thing you're really using to try to allow the LLM to perform better is your prompt. You're just playing with the prompt, using different sentence structure, adding different sentences to try to make it do the best job possible. You might ask it to format a specific way. You might ask it to div to things, etc. But all you're playing around with is the prompt itself. The pros of this zero shot is it's very, very easy, and it feels like magic. There's a reason why ChatGPT kind of like took the world by storm. It just feels unbelievable. Even though, some would argue like on the ML side, this is a architecture we've had for a while. And it was more of a step increase as opposed to a whole new thing that didn't exist before. But what really happened, in my opinion, was that we finally crossed the barrier where it really felt like magic. It really felt like almost unbelievable, where things we had before, like other large language models we had before, even things like BERT, felt extremely valuable and felt like magic to data scientists, did not necessarily convey that same effect on an average person. Like if your grandma looked at BERT building embeddings, they wouldn't think this is magic. But using ChatGPT really has that effect. The cons, which are well documented at this point, is it tends to hallucinate. I'll just make things up. it's stale data. So like if something happened yesterday and you ask it about it, it won't no, it won't have been trained on it. It doesn't really have it's undifferentiated. So if you are releasing this as an internal product and you're asking it questions, like anyone can do pretty much the same thing. If all you have to differentiate is the prompt, chances are it's not really differentiatable at all. You might as well just use ChatGPT itself. And you can't really contextualize it. Like you just hope that it kind of already understands what you're going to talk about. And like we said, in practice, lots of times it does, but many times it doesn't. For example, if you ask it intimate details about Featureform's API, it will just make things up or just not know. Whereas if you ask it generally what it is, it will kind of give a decent answer. So one of the things I see a lot of people talking about is fine-tuning. The concept of fine-tuning, it feels like traditional training machine learning, where you have example data, which are in the form of prompts and responses, which you could argue is really the same form as features and labels. And you train your model, you're actually fine-tuning the weights to achieve better performance for your use cases. A lot of people, especially companies I've seen in projects that were using traditional models before, they immediately go to fine-tuning first because it feels like ML. It's really similar flow to ML pipeline. You build a training set, you train the model, you keep track of experiments, you version those models, etc. It's a very easy way to take advantage of really large data sets. And for situations, there's this concept called RLHF, which is reinforcement learning from human feedback. It's like kind of another flavor of active learning. And there's many words and terms over the years that are essentially the same concept of you are almost in line, like giving feedback to this thing so it can do a better job. You're giving it really good data. So yeah, it kind of feels very similar to like training a traditional NLP model, except that it already works super well just out the gate, typically. The cons, it still will often hallucinate. Fine-tuning is in practice much more about style. Like the model tends to learn more about style rather than memorizing facts. So it will more likely kind of mimic the style of the question answer that you have, as opposed to actually remembering exactly like the numbers and the values and all that. It typically takes a lot of data. There's been new papers that it actually doesn't require that much data, but the data has to be really good. Regardless, you need to really focus on having a well-curated data set. Finally, because you're training at the weight level, you're training at the model level, everything you train with is available to an extent, everyone in the model. So if you ask the right prompt, you might be able to get us to spit out something that it shouldn't do. For example, with the GitHub Copilot stuff, something that we've seen a lot is if you start writing a comment and you write a comment that you know exists and you let it finish, it will just like copy and paste the code. So like kind of spit out what it was trained on. That can be really bad if someone figures out how to make it spit out some other user's personal data, for example. So there is kind of a security and a risk problem that comes with fine tuning, especially on data that should be private. If you're fine tuning on generic data, like, hey, I want to make my LLM talk like a pirate. So I just found a lot of generic like books with people who talk like pirates and I fed it with that, then this doesn't really matter, right? And it will actually do a very good job. But if you're trying to make it memorize user data so that it can kind of do a better job, it can be risky. If you're doing things like docs, like if I was to fine tune it with our docs, one, it's probably not enough data. Two, it likely won't actually memorize the API. So it'll still hallucinate. The third, and in my opinion, the one that most people should be doing for most use cases, is commonly referred to as RAG, or retrieval augmented generation. So generation is what the LLM does. Augmented is you're augmenting the prompt in this case, you're contextualizing it. And retrieval means that you're using databases to retrieve that context, to augment the prompt, to make it generate better results. So this looks really complex. I'm going to break it down, I promise. But this is how it works kind of end to end. The pros of retrieval augmented generation is this is the only one that really significantly drops the risk of hallucination. Now, it doesn't remove it. Anyone who's claiming that RAG actually removes hallucinations is lying to you. It does make a huge difference, though. It's safer from prompt injection because the data that you contextualize is at the prompt level. If I ask a question and Mickey asks a question and we both get our prompts get contextualized of our data, the model won't itself know our data. So the data kind of is in the guarded wall of that conversation. It will never be able to like accidentally leak into someone else's context. It's very high quality, works really well. It's also iterable, which I think is really important. With fine tuning, it's still a bit of like, try making your data better, try playing around with the data set, try breaking up in different ways, etc. With contextualizing a model, like because all you're doing is like kind of injecting data into the prompt, you can just come up, it's almost like feature engineering. You can just come up with, if I gave it the user's age, would it do a better job? If I broke down my content in this way, would it do a better job? So this kind of a experimental feature engineering style effect that happens here. The cons is, like you saw, it's kind of complex. And it also requires enough private data that is like specific enough per user or per conversation to be useful. So if you don't have that, then don't bother. But in situations that you do, for example, if you are a health insurance company, you have every user's private data. You build a chatbot, they're asking questions to it. You probably want to contextualize the chatbot with their private data. But you definitely don't want to accidentally fine tune and have it so other people can ask and get that data if they use prompt injection. So a lot of people just pick RAG or fine tuning just based on what they think or what they learned about or what feels more natural. They, in practice, kind of fulfill two different needs. There is fine tuning is much more about style transfer. Like if you're trying to make it speak a certain way, fine tuning works really, really well. RAG is much more about cutting down hallucination. It's much more about giving it the right content and data so that it uses that correctly in its generation. Fine tuning needs a lot of data. RAG, it's different. You don't need a ton of data per se. You just need relevant data to actually contextualize prompts. What that means kind of depends on the use case. Fine tuning is still prone to hallucination, and RAG dramatically reduces hallucination. I think this is the big part. It's a big takeaway of the big difference is that fine tuning is style, but really it's just it's not memorizing things well. It's not really what's made to do, as opposed to RAG, which will force it to use the data to an extent. Not force it, but it will be much more likely to use the data correctly. Fine tuning is very simple. RAG is far more complex, which in a sense also breeds opportunity. Because if it's more complex, there's way more levers for you to play with to get the results you need. I'm going to take a second answer any questions that come up. If you have any questions, throw in the Q&A. My next thing I'm going to talk through is I'm going to break down this workflow and talk about how RAG actually works. So there's two questions here. One is, does it matter which vector database is being used? For example, Pinecone, Weaviate, etc. And then like Postgres and Cassandra, which also support vector databases natively. I will answer this question through this next section. How long of a context can a chatbot support? Is it possible to keep the context relevant to a user interacts with a chatbot? Let's say a user wants to change his flight seat on a flight they've already booked. Yeah, so this is the idea of a context window. So when you're building a chatbot, you don't necessarily have to treat like every like back and forth like ChatGPT might. One common trick, for example, is while you're chatting, you could, if you feel like there's been a lot of conversation, you could actually ask an LLM to summarize the conversation so far and use that as context. These are really good questions. Yeah, and then the last question here that I see is for data processing, is it real time or is it more batch oriented? It depends on the feature. I think as I go for this next section, it will clarify some of these much more. So I'm gonna mark these as answered, and then if I didn't answer them for this next section, feel free to re-ask. Okay. So, okay, the point here is to contextualize our prompts. So what does that mean? Oops. So let's say you are a bank and you have like a chatbot and someone asks, how should I be investing? You probably want to know how much money they have, how much they spend a month, what their spend categories are, like what they're spending money on. You want to know what their age is. You want to know, there's a lot, like even variables like where do they live, how much do they pay for rent, etc. It's going to really help. Do they own a home or do they are they renting? These are all features you probably want to have to be able to answer that question well. Now, an LLM is trained on kind of the full corpus of the internet essentially. And it will give a pretty decent answer to how should I be investing. Even if you just give it just these features, it will do an even better job. If you want to go a step further and you want to limit the chatbot to, or the LLM to use maybe content you've written before, or you want to kind of root it in reality, like, hey, this, like, we are bank X and our bank has written a lot of content about how people should be investing. This is kind of our view of the world. We want to make sure that whatever the LLM says is it doesn't hallucinate and go off the rails and say something really ridiculous, like throw it all on whatever, on GME. And you also wanted to probably follow, kind of be consistent with your content. So once you get all this information, then you fit into a prompt structure. So given the user has, for example, it might look like given the user has these attributes, age, money, whatever, and using this content from our blog as context, and then maybe like a set of paragraphs from the blog, answer this question, how should I be investing? So this is actually what you will send ChatGPT. So you see that it's still just a prompt, but you have augmented it with information you've retrieved, retrieval augmented generation. So that's kind of what this whole complex looking thing does. Now, let's talk about the two pieces of it. So first, you need to actually have that information, those features, which could be, again, like the content. It could be the analytical features, like how much they spend in a given month. So how that looks in practice is you typically will have like documents, like more typical, like your blog posts. And the example I'm going to do is like our transcripts from our podcast. You'll pre-process them. The pre-processing includes things like chunking. Like, how are you going to break this down? Because essentially every piece of the processed text is context that fits into the prompt. It's essentially the feature that you structure into the prompt. And so how you can take a blog post and best break it down, how do you summarize it, how do you kind of maximize for information, is an open question. There's a lot of people working, not enough people working on it, in my opinion, but there's definitely like kind of a focus there on how to do that. And then the more traditional analytical features, like how much money do they have in the bank account, that will look like a very typical feature engineering pipeline. You might have just data in a data lake, whatever, Snowflake. You'll be performing feature engineering, which could look like data frame transformations. It could look like SQL, and that will generate your features, which you store in an inference store, which in practice looks like a key value store. And then, yeah, the vector DB, I'll get into what that means, but the vector DB in practice is almost like a way to get the most relevant pieces of content to a query. There was a question earlier about streaming versus batch. It really depends on the feature. Some features change quickly. For example, you might want to know the last thing a user looked at. Or the last, like, let's say you are building a chatbot that's kind of like intercom style, like trying to make people, sell people on the site. You probably want to know what they're doing right now or like very recently. So that probably needs to be streaming features. Things like the blog posts, it could be done on like a cadence, like every 24 hours. It could be streaming. Things like what's their the long story short of this is it depends on, there's this idea of freshness. So how fresh is the feature is gonna, in theory, the fresher the better, but in practice getting some features to be really, really fresh is hard or impossible. And also in practice, the more you get it towards being extremely fresh, the harder it typically is and the more it requires. For example, you might have to build a whole streaming pipeline, a Flink pipeline, make sure you have exactly one semantics, like all these things you'll start to think about, which you wouldn't think about if you're doing batch come into play. And we support all of these different kind of styles. So once you have your databases filled with this context, and the inference store, again, is the key value store typically. It could also be Redis. The vector database is a vector database, which can also be Redis. So both of those can technically be the same database, even though we're treating them as separate things here. What happens is a user asks a query. So an example I gave earlier, it's like, what should I be investing in? You'll pre-process that query. That could be a lot of different things. It's kind of all about, it really depends on the use case. In this case, you might just do nothing. You embed it and query from the vector DB. I will explain what that means soon, but just think of it as this kind of operation that just says, give me things like this or relevant to this is kind of the operation. You might also grab like the user ID and other things to be able to grab relevant features. You would then structure your prompt based on all the features you just got and feed that to the LLM. And that will, again, generate your response. So end to end, you're taking your data, raw data, you're pre-processing it into relevant context that will eventually be used in some prompts. You put it in the correct databases to allow for the correct type of retrieval. And then per request, you pull context, you feed it into the prompt, and then you ask the LLM. So if there's any questions so far, as always, feel free from the Q&A. There's a question of, will this webinar be posted online? And the answer is yes. If you actually follow us on LinkedIn or Twitter, we'll be posting it on both. So you'll be able to see it there. I believe we'll probably be sending a follow-up email that has it as well. Cool. So what's the role of the vector DB? Like, why do we have it? It's just an operation to generate, to take a prompt and retrieve relevant text to that piece of text, semantic search. The way that you store things, so in the key value store, you have the key is like a string or something that you'd use to do like lookups. In the vector DB, the key is an embedding. An embedding is literally a vector, like it's literally like a point in space or like an n-dimensional float list. In practice, what it is you can take sparse data, and text is actually sparse data. Like think of how little information is like think of a long book and how much information is actually in the book. Like text is a very bad way to typically squeeze information. And so it's very sparse. So you use an embedding to try to kind of get a dense representation of that. And then embeddings in particular have a property where things that are close together in vector space. So if you have 3D space and I'm here and someone else is here, like that would mean we might be similar compared to someone who's way over on another side. The way it does that isn't really relevant. You can just imagine that when you use an embedding model, it will take your text, turn it into a vector, and that vector will have the property where other pieces of text whose embeddings are close to it, like literally like close to it by close sign similarity or something else, but are viewed as nearby, are considered similar to the model. And these models are really smart. Like they will kind of understand what the text is trying to convey. It's not just like counting how many times a word appears, etc., which is another way to achieve this, but we get much lower results. How do we use them? We use them, we can actually feed them as features to models, which is something we used to do a lot for recommender systems. We would just like take a video embedding and feed it in. Just instead of putting the video ID, we would just put the embedding in, because embedding also is like kind of a dense representation of this concept, where an ID is kind of sparse. It's just an ID. The other place we see it and is more common for what we're talking about here is for nearest neighbor lookups. So just like being able to search based on an embedding. How do we create them? We use embedding models. And embedding, like they're a type of transformer, which is why I have the transformer there. One of the first really, really good embedding models was called BERT. BERT was actually a kind of successor of Elmo. So there's a whole weird Sesame Street kind of thing that happens in embedding models. Those models are used to generate embeddings. These ones I'm talking about are for text. You can actually generate embeddings off of images, audio, many, many things. But for this, I'm just talking about text. Embeddings and prompts are cousins. Really what I mean is things like GPT and things like BERT that generate embeddings are kind of two sides of the same coin. They're all based on the transformer architecture. Specifically, BERT is an encoder only, so it encodes things into embeddings. And GPT is a decoder only, so it kind of turns text to text. There's also encoder decoders, which is out of scope, but very interesting point of research. This isn't new. Vector databases aren't a new concept. Like I've probably built like 4 vector databases in my career before all these vector databases existed. A lot of people will have similar stories because before vector databases exist, we would just use the raw index directly. So we'd use things like Spotify had Hanoi. Eventually, Facebook released Phase. This is like using a B tree instead of Postgres. Like underneath the hood, like Postgres is just using a B tree or something like a B tree to do your queries. But do you really want to work on that low level? Not really. You kind of want to build a database around it. So we used to just hack stuff around it. Nowadays, there are very well properly built vector databases like Redis. There are many. There's Redis. There's people mentioned Pinecone, Weaviate. There's even like Postgres and has its own implementation, PG Vector. When we would do vector search for recommender systems, we would look really deeply at the recall of these, because these are approximate neighbor lookups. So the results you will get from like the Postgres one and the Redis one and the Pinecone one are likely to be different. They'll be of different quality. Like for example, Postgres in particular uses something called IVF, which is typically far lower quality than the algorithms that like Redis and Weaviate and Pinecone use. That said, it's also, if you're running Postgres, all your data is in Postgres, it might be easier to just use Postgres. So there's a balancing act. So you have to decide, and based on quality and based on how that quality fits into the prompts. Like maybe the nearest neighbor lookup isn't as good, but in practice, it ends up being about the same. And simplicity is worth the trade-off. It's like many problems in engineering, it depends. But it is not as cut and dry as they're all the same thing. They're not. So I've explained RAG. There are all these tools we just talked about. There's like OpenAI, there's Hugging Face, like there's Llama, there's Spark, there's Weaviate, there's Pinecone. There's like all these things exist to store data, transform data, vectorize it, store it in vector DBs, use LLMs, etc. So we're good, right? Like we're done. Like everything's here. Not quite. In practice, what's missing is an orchestration framework and a metadata framework. You need a way for data scientists to use to essentially not think of what it would take and the crazy scripts and stuff that people write to orchestrate this process. Like we've seen some crazy stuff that people have done. It's usually really hacky. There's no versioning. There's no like keeping track of, hey, I have this embedding in this vector database. Where did it come from? How do we build it? How did it compare to this other one? You know, maybe we should A/B test them. All these concepts and this orchestration framework doesn't really exist. And things like traditional orchestrators just don't understand this workflow well enough. Like they don't really allow you to orchestrate the retrieval, for example, even if they might kind of sort of be able to orchestrate some of the pre-processing. So what you need, or what a lot of people need, and a lot of people end up kind of trying to build a lightweight version in-house of, is some sort of framework and orchestrator above this all. And so Featureform is built from the ground up to do that. It's an orchestration framework and a metadata framework for all features, including embeddings, including prompts. I'll show an example of that soon. Someone asks, Featureform has embedding hub. Was it another vector database? Is it still an option? Yes, we actually built, it's actually something I built personally a while back, was Embedding Hub. Embedding Hub is a vector database. We have decided that there are enough vector databases in the world. We don't think we are uniquely set to build the best vector database. We think that, you know, people like Redis are doing a fine job. Where we focus and where all of our focus has moved to is, rather than building another database, is actually building that orchestration layer, the framework above all the databases, all of the data that makes all of these things work together. Getting to the point I just mentioned of like, just because you have Hugging Face, you have OpenAI, and you have Redis as a vector DB and a key value store, and Spark maybe to pre-process some of this stuff, doesn't mean you're done. It's kind of like now you have to make all this stuff fit together. And anyone who has a background in building data pipelines knows that that's typically the hardest part. To show that, I'll show you some memes I wrote. This might look familiar. Anyone with a data science background has probably done this. I do it. I've done it quite often. And so part of building Featureform was to kind of solve this problem. The other problem that we see a lot of, like, for example, when you have that RAG framework, you'll end up with like feature table underscore v2. And it was built using Untitled 128, the IPy notebook. And then, well, we use Spark to process and build these features or these embeddings, but now we need to get into the vector DB. So we have copy feature to Redis.shell. And, you know, our data scientists or whoever are Spark submitting jobs directly or have these crazy YAML files to try to orchestrate all this creation. And none of it's documented. Super common. We see it all the time. It's part of why Featureform exists. And finally, just to kind of cherry on top, like I'm sure we've all seen some flavor of this in our day-to-day work. These are the problems that I think are overlooked with LLMs. Like a lot of people are focusing on the technical pieces, which are obviously a really good place to focus. But what's missing is this framework above it all to really orchestrate all this end to end. I'll get into some stuff. I'm going to give a demo in a moment. I'll take a second to answer questions. In this use case, would you be able to talk about when folks should use a vector database service from Pinecone or Weaviate? Looks like Redis or Postgres or other similar. already available vector base for small teams should be good enough. And since the looks of it, most vector databases, most of our needs for building embeddings and run small queries across those embeddings. From what I understand, those embeddings are not that large. The embeddings are not that large, really depends on your use case. Again, like every data set's going to be different. Some data sets are giant. Like for recommendation systems, like we actually, even like one giant node running a very similar algorithm to what like a lot of vector databases uses wasn't enough. We actually had to horizontally scale it, which was not fun. So it depends on how big your database is. In terms of like the Redis versus Postgres, you should look and try to understand, because they all share, which algorithm are they using under the hood. Postgres, to my understanding, pgvector is an implementation of IVF. IVF scales really well, is really simple, but is typically far lower quality. Redis and some of the other vector databases you mentioned, like Pinecone, Weaviate, they all are using some flavor of HNSW, which is the one that Facebook actually came up with and is a much higher quality algorithm. Now, like I said, in practice, so I guess what I'm getting at is like the Pinecone, Weaviate, Redis are probably all using something that looks a lot more similar or likely have different results in quality than Postgres. That said, the Postgres might be good enough for you. It kind of depends on what you need. And the Pinecone versus Redis versus Weaviate, there's like a lot of questions to ask there. Like, do you want, like Redis has obviously been around the longest, for the most stable. The other databases is all they do is vector DBs. They have very different APIs too. Like Weaviate's API is quite a different animal than Pinecone's or Redis's. So there's a lot of things to think about. There's no right answer in the sense of like everyone should do X. Like anyone who says that is again like has stuff in the cell. In practice, it depends on a handful of variables. Cool. So I will jump into I'll kind of go through this quickly because I'm kind of getting towards time. With a lot of companies, we see traditional ML, kind of RAG style SLMs, even like literally trained LLMs, and large context window LLMs where they're actually feeding, rather than using a vector database and retrieving relevant context for a query, they just put everything into the LLM context window, which is really expensive, but in some of the newer context windows, it's actually possible. It's kind of nuts. All these things will exist. There's different trade-offs on like speed, explainability, cost, quality, and all these things will continue to exist into the future. Like they will all coexist. And the feature engineering that will be used for traditional ML will be used for LLMs, vice versa. Like all this stuff is kind of the same way that, hey, like, we use TensorFlow for a deep learning model here, and we use random forest here. It's not like one killed the other. It's just they now live and coincide, and they're just used for different use cases. And I think the same thing is true here. Okay. And for traditional machine learning, like kind of the same thing. Like you're taking raw data, you're transforming it, you're building it to features. For all the things I've mentioned, looks very, very similar. So in practice, the APIs for both in Featureform look very, very similar. The only difference is in the LLM style, we have more of a support and a focus on vector DBs because it's a very common use case, as opposed to in traditional ML. It's definitely not as common. It still happens, like for recommender systems, example, but not as often. So I'm going to jump into a demo. Jump here. I will assume you guys can see this notebook unless someone tells me otherwise. So what I've done is I've deployed Featureform on the Kubernetes cluster in AWS. I've deployed a bucket in S3. I have some data in it, which is just our podcast transcripts. I deployed a Redis Labs instance. So I deployed Redis via their cloud service. So The Redis vector DB, you need to, it's a module and it's part of something called Redis stack. So it's, if you're running Redis today, you might not have that module. So just FYI, you need to have a module for this to work. And so an easy way to do it is just use Redis Cloud. They have a free tier. You can also, they have a Redis stack Docker file you can use as well for testing. So yeah, I rested Redis. So this is Featureform. So Featureform, you deploy it, you connect to the client, and what you're doing, the name Featureform comes from Terraform. So it's kind of this idea of a declarative language to define all of your features, all of your transformations, all of your training sets, your infra, etc. So in this case, I'm registering Redis, which is just a Redis endpoint that I deployed. I'm registering my S3. I'm registering a Pandas runner. So I'm going to use Pandas to build these transformations. You could use Spark, you could use Snowflake. It doesn't really matter. But in this case, Pandas was easy enough. I'll apply this stuff, which will build it. I can actually look at my dashboard where I can look at features that exist, providers that exist, sources that exist. I can look at how they're defined. I can look at the data in them. I can look at where they were built, who owns them. I can look at a user entity and look at features associated with a user. I can kind of really understand my DAG and my resources here and search and discover as well. I register my files. I transform them. So a lot of this transformation, like this one in particular, is literally just like clean up, parse, very traditional stuff that we used to do way before LLMs existed. In this case, very similar as well. We're just kind of building out our transformations. We're just cleaning the data. We're building it and formatting it in the way we want it. So everything so far that we're creating, notice that in Featureform, when you build the transformation, this is just the same SQL code you'd expect to run. This is literally just pandas. You tab over your code and you put it in kind of a function and you annotate it with the runner. Featureform, when you apply this, you will send this to Featureform. Featureform will run it for you. You can set up a schedule. It will store and index the code or the features and transformations for you, so you can reuse them, you can share them, etc. So if you're working on a team. And then the embedding generation, I think someone actually just asked this question. So the embedding model in this case is in Hugging Face. But the actual transformation that takes the text, so it takes the input and then applies, essentially encodes that text as an embedding. That part is orchestrated in Featureform. So you can see that transformation. You can see the different sources you've built your embeddings on, etc. I'm purposely using a low level API here to show you what's happening under the hood. So all it's really doing is taking the sentence transformer from Hugging Face in this case. OpenAI has one, there's many, and you are encoding that text. And when you vector, you can see here, like when I showed the data frame, so I transform this into a data frame, you can see the embedding associated with the text, which is a very long row here or column here. So now I've defined my transformations. I've defined my my embeddings transformation as well. Now I can finally start defining the features. And in this case, I have one feature, which is just the original text before I embedded it. And then I have another feature, which is the embedding itself. And notice in this feature, I am specifically telling it to store it in Redis. So Featureform will orchestrate building these embeddings. It will then orchestrate materializing that embedding into Redis. And then retrieval, which I'm about to show, it will actually orchestrate the retrieval as well. It will also take care of versioning, management, and other things that you would expect, even governance, if that's relevant. So yeah, and then finally, let's talk about retrieval. So everything we've done so far in our picture of RAG has been this left side, this part. Like we have taken the documents, we've pre-processed them, we've embedded them, we've put them in the vector DB. So we've just done all of this and orchestrated this all and defined this all in Featureform. Now we need to define the request or retrieval. The way we're going to do retrieval is we use these things called on-demand features. On-demand features happen at retrieval time, so per request. So per request, we get these parameters, and one of the parameters we're going to give is the query. We will take that query and literally embed it and then use Featureform's client to get the nearest neighbors. So we use the nearest call in the Featureform client to get the 3 nearest things. I can test it out. I can call these features and it will show a list of the most relevant podcasts or pieces of content. It's actually not the podcast. It's actually the paragraphs. So like every kind of conversation or part of the conversation we put as a different document. Then we build this prompt, this contextualization prompt, which is very similar to what I was describing down here. Given the user has these attributes using this context, answer this question. For this one, we do using the following snippets from our podcast, answer the following question. We literally just like append all of the features that we just got, and then we just append the parameter, the original parameter user wrote. So putting it all together, I use client.features, contextualize prompt. That's this on-demand feature I built. I take a parameter, and let's say the query is this enterprise MLOps. It will automatically do retrieval for me. It will then build this prompt. So using the following snippet, blah, blah, blah. So now I can actually use it with OpenAI. I can use client.features or Featureform to client.features. I can get the contextualized prompt. I can give it the query. And then it will, I can pass it to OpenAI. So the whole creation is orchestrated. As you add more documents, it will automatically happen. It will all be materialized in Redis automatically. You can tweak and change your DAG. You can see the DAG that was created. You can change how retrieval works. But once it's all there from your use case or from the end use case, you're just asking for the contextualized prompt and you get it. I know I breezed through that. I know we're about to be at time. If there's any last questions, feel free to throw them in chat. I'll still be around for a few minutes after, but I understand a lot of people probably have meetings coming up. Is Featureform doing orchestration? Does that include embedding generation? Yes. So like I showed, we're actually orchestrating the building of the embeddings. Now, to be clear, we don't have our own embedding model, but we are orchestrating the creation of these embeddings. We view ourselves, even though we call ourselves a feature store, a virtual feature store, in practice, we look more like a feature orchestrator and a feature metadata store rather than like the data store. So our view of what a feature store is very much fits this workflow. I wouldn't necessarily say that a traditional feature store really makes sense in the same way in an LLM workflow. But great question. Cool. Well, thank you all. If there's any last questions, again, like I said, I'll be around. I know a lot of you have to drop off. We'll be sending a follow-up email. And if there's any questions that come up or you have any questions for us, feel free to reach out. My email is simba@featureform. I'd be happy to, I read my email. I'd be happy to answer any follow-up questions you might have in the future. And lastly, we are open source. So everything I showed you, you can just, you can Google, GitHub, Featureform, and you can use everything I just showed you. Awesome. Well, if there's any last questions, I'll be on for a few more minutes. Otherwise, thank you all very much for sticking around. Cool. Shab, I made you host, so you can wind things down.
Awesome. Yeah, thank you everyone for coming, and I will be sending up a follow-up email with the resources that were shared during the webinar, as well as a brief survey and a link to our community. Thank you so much.